around 10,000 cubic meters. What is known so far, because it's been characterized, it's ARPA 1, and the total amount of material is around 3,500 cubic meters. So a little bit of the background. So basically in the 90s, the two illegal landfills were discovered. In 2005, Linden was, HCH actually was found in milk samples from the farming areas in the region. And this led to identify the site as a site of national interest, and obviously prohibiting farming in these areas. And unfortunately, this is still ongoing. And it's one of the main concerns also of the public authorities, to give back these areas to the people that lives on them, literally. So after this, there was quite a bit of an activity. Budget was made available. So a couple of years, 2006, 2008, for characterization of soils, waters, and sediments. This was divided in two phases, as we will see. This led to some remediation activity until 2012 for ARPA 1. But then things kind of stopped for many years. So environmental monitoring was not done since then. Luckily, obviously, the biomonitoring of milk and forage was done. Again, for several problems: lack of budget, changes in the administration, and so on. A little highlight on the remediation work that took place in ARPA 1. Basically, it was excavation, removal of material, and construction of a landfill on site in order to dispose both the contamination, the HCH, and the soil. And this was done until 2012. And now there is an ongoing process to start a similar activity for ARPA 2. But actually, there's a big problem to define the background values of beryllium, and this stopped all the activities for a long time. So again, issues that I think are quite important to understand, the timing and what's happening. So back to our consultancy. Basically, from a preliminary gap analysis that we did together with the public authority, we decided to focus on the study and characterization of the fluvial sediments. And this is typical an activity. I mean, sediments in general are left towards the end, so we decided to focus on that. This was the initial simplified conceptual sites model used for the banning of the areas. So the source, the industrial area, the transport factor, the Saco River, and the targets, both alluvial areas and fluvial sediments, which is represented in that graph, basically representing the expected trends in the fluvial sediments, showing a decrease in concentrations along the river. We will actually see that this is not the case. So we started to update the CSM. We started to collect data and populating the database. This was actually a very useful activity because it had never been done before. So there was a huge amount of data scattered in many different offices of the authority, and nobody have really put it together until now. We mainly focus on three elements. So those two characterizations that I mentioned, 2006, 2008, characterization of sediments, and water monitoring. So this was the phase one. So activity done on sediments and floodplains. Basically, we started to see some trends, some focus areas, some hotspots. In general, gamma HCH, we noticed that it's less present and often associated to alpha or alpha and beta HCH. This is an interesting slide. It's a close-up of an area, but it actually shows that the pollution is located inside, but also outside the flood areas. And this actually suggests that the Saco River is not the unique transport factor. So again, this is very useful to update the CSM. As a matter of fact, there's other like wind, agricultural activities, roads and pipeline construction, and so on. So very important information. In terms of deep soil, we notice that values are pretty low. So in general, this suggests that the transport is less efficient in the downward direction. And then fluvial sediments. Again, we have some concentrations, some patterns, and in general, gamma HCH very low or not present. Then we did some interpolation, and basically two main areas emerged, which we called N and C. And basically we have some hotspots in terms of sediments and also topsoil. Phase 2, very similar approach. So again, fluvial sediments and goldenary areas. This is a general view. Contamination, again, mainly alpha and beta. This is the upper part of the southern part. And there is a distinction between these two areas in terms of alpha and beta and alpha HCH alone. And again, some interpolation. And basically, we came up with one hotspot area, which we called S. So we're talking about three main hotspots, main focus areas along the Saco River. Some lessons learned. The main points, as I said, gamma, not much presence. Coexistence of contamination and not contaminated samples inside and outside the flooding areas. So again, this suggests that the floods are not an effective transport factor, but rather the opposite. There's a transport of contaminants from the goldenary areas towards the fluvial sediments. Probably due to runoff, and also dispersion of contaminants outside the runoff lines. Similar conclusions and lessons learned for phase 2, 2008. Then we moved into water. So using the monitoring data from the ARPA Lazio, both groundwater and river water. So what did we see? Obviously, there's a presence of contaminants in groundwater in the industrial areas of Colleferro. So we're talking upstream, let's say, north. Unfortunately, there's no exceeding limits south of Colleferro, which is good, but unfortunately, there's no data available south of Frosinone, so for the lower parts of the river. About river water, we noticed pollution around phase 1 area survey. So again, the northern part of the river. But we also noticed that HCH isomers are below limits on the Colleferro area, but above until Frosinone city, which is more or less midway of the river. So lessons learned, pollution and groundwater present in the industrial area. In general, the waters, not the sediments of the river, show not a big impact. Unfortunately, considering the size and the extent of the area, there's not much data available. So this is a big limitation, let's say. Just one other slide on sediments showing the presence of these strong peaks and secondary peaks. Therefore, going back to that initial graph, the trend is not actually of a constant decrease in concentrations, but rather the presence of peaks controlled by both external sources and river dynamics and river energy. Which led us to update the CSM. And the main points, the main features are the presence of these three, let's say, macro areas, not spots, but really big spots. And there's we counted about 70 potential hotspots. And this obviously needs to be checked. But at least it's going to be a targeted activity, let's say, compared to characterizing the whole river, which is mission impossible. we notice the presence of many transport factors, and this transport towards the fluvial sediments. And then we have a secondary transport of sediments, which causes a redistribution of HCH, which produces minor peaks of concentration. And also redistribution and transport of temporarily stored HCH-rich sediments, preventing a downstream dilution of HCH along the river channel, with potential of redeposition of sediments into clean areas. So this is, in summary, the updated CSM. So two main sources, the industrial areas and the hotspots, 3 transport factors, Saco River, the runoff, and wind. Main targets, the fluvial sediments that also produce secondary peaks in pollutants concentrations. So moving on and ending up, the focus was to present the updated CSM, but obviously also provided a consultancy on the characterization to be done. So we defined these priority areas. We decided that a clean area should also be studied in order to define baseline values. I mean, there's a need to identify suitable sites for monitoring stations for continuous monitoring. And also we suggested the use of, let's say, low-cost technologies for indirect surveys before planning a targeted characterization of priority areas. So again, the idea of this was to provide an idea for a characterization plan, optimizing costs, optimizing timing, because as usual, I mean, budgets for the public authorities are limited, and it would take too long and too much to study the whole area. It would not make sense. And finally, the remediation strategy. So as I said, we're talking about around 6,000 hectares, but considering the study, the interpolation that we did, and the analysis of all the data, we kind of restricted the surfaces that would need intervention to hotspots and impacted areas. So a much smaller number in terms of surface, but still a huge number in terms of volume, of course. So this really will require, let's say, a comprehensive, holistic approach, integrated approach in terms of finding the right technologies, possibly on site, in situ, possibly low cost, like bioremediation or phytoremediation, things like this. And I really think that the soil thematic strategy, which will come out today, would be an important point and very, very synergetic with this kind of activities, because again, the extent of the area calls for a need to a systematic approach. So it's not just an industrial area to be remediated, it's a very big diffused contamination. And it's not only removing the contamination, but it's really giving back these areas for activities. So again, I think the soil thematic strategy will be very important. So I'm very curious to see what's going to happen today. Thank you.
Thank you very much, Cosimo. So we open now the floor for questions. John starts. Very good. Early in the morning.
I think it's an impressive talk and complicated situation. I was just looking about sampling, and I was listening yesterday to Pavel about all these tree issues and sampling. Have you been talking to each other?
Not yet.
So I think there is really something what the different projects are doing. That's why we are cooperating. There's so much synergy that we can help each other. And I think things are on the table. So I hope that you find each other and move on. Cross-contamination on the know-how would be very good.
Yeah. If I may add, does this work? So I will certainly take the opportunity. I think it's a very good suggestion. We spoke a little more about with the group of the Mulder River case, which was also very useful, at least to have some ideas, for example, for the gamma ray spectrometry and things like this. Also, since there's many actors involved in the Valle del Sacco site, we started to discuss with other groups and public authorities that are working on the sites. And by the way, this is a good news. Last week, a new tender just came out for the characterization of the agricultural areas. So this is an activity that will take place next year, I'm sure. And the idea of the authorities to use the GIS and the database that we set up to update it and populate it with new data. So finally, I think there is a bit of a convergence in terms of how to use data, how to organize it, and how to read it and really to use it in a more efficient way. So I think this is already a promising result, let's say.
So thanks for both speakers, very interesting presentations and case studies. My interest is in the data and knowledge management on the long run. What we watch in Austria is we build nice conceptual site models, but then the project ends and the people disappear and the knowledge disappears and data is dry. Yeah. So how will you manage with both cases, or what would be your general recommendation for future keeping the memory of all the data and knowledge you generate?
Thank you. I think in our case, it's maybe a little bit easier because with the state agency, the LAF, there is a government authority that can maintain this GIS system as long as they want, and you know, because it's their official task to do something with this data. I think it's safe. For the project, we established this geographical information model. It's up to the EU how to produce, how to proceed with it. I was surprised yesterday with the discussion that there's so much struggle getting information. I mean, we have a Freedom of Information Act in the European Union, so it should be made available if somebody has a correct interest in getting data, then it's up to the governments to make this data visible and usable. In the project, we noticed it is difficult to get all this data and to make it comparable, even if it's, especially if it's older. So there's quite some work behind it. Can you compare the methods of the analysis and all that? But once it's there and it's digitalized, I think it's a very good and sound base for future work.
Yeah, maybe I can add something to that. I think the keyword digitalization and digitization is the key here. In the past, even as a state agency, we had the problem, there's some report, everybody reads it, and then it's getting dumped somewhere and everybody forgets about it. But now I think it's different. If you integrate it, for example, in the GIS system or something, it's there. It's a red dot or a blue dot on a map, and you can see, oh, something happened here in the Mulder River, for example. So future generations can just see which reports are available, and so they don't get lost anymore like it has been before in some archive.
You want the Italian approach. That's it.
That's always the best.
It's paperwork. No, I'm really on the same wavelength, to be honest. I think, I mean, we have the technologies nowadays, and digitalization is the key. And we actually noticed this. Okay, we had the COVID problem, first of all, so we couldn't go to the offices, I mean, during the consultancy period, and this was really a big problem. But we were talking to the authorities, and literally they were saying, yeah, we have some, you know, some paper files in one office, then they move to another office, then people change and they left with the, you know, the paper with them. Some paper we used for, I don't know, maybe for fireplaces and, you know, things like that. So really the key is to digitalize it, maybe even use, I don't know, blockchain and things like that, you know, make really good use, strong use of technology that is nowadays available. So store it safely and make it a good use. Yeah, I think that's the rest.
Yeah, I just wanted to add that on the GIS or the GIM system we are going to transmit to the European Union, we include all these reports on the different tasks and the sites. So this it will be available for the public to consult.
One question. We have the European Environment Agency, the biggest database France in Europe. There should be a link or not? I mean, all the countries are giving data to the European Environmental Agency, so there should be a more logistic approach that somehow this gets together and available from region to country. There should be something in common, or? I mean, that's Europe in the future, or? What do you think, Barbara?
Well, actually, member states are not really transmitting a lot of data when it comes down to contaminated sites and soil contamination. The information that is transmitted to the EEA is basically how many contaminated or potentially contaminated sites does a country have, but that's about it. We don't know where these sites are, what the pollutants are, etc. So it's not really correct what you say. It's probably true, or there's more exchange of data for water, for air monitoring, and etc. But it's also something we certainly want to see improved also in the future, and which you will be able to read also today, I think, in the soil strategy.